The iconic shape of the Enterprise from the Star Trek TV show and movies provides a unique design that fits nicely into a spinning habitat for exploring our solar system. This small design is 600 feet in length with a saucer section of 292 feet in diameter. The first floor, the spinning level furthest from the center, is 133 feet from the axis, making 4.7 revolutions per minute at a spin speed of 45 miles per hour to produce 1 g of force simulating Earth's gravity. It is noted that the Coriolis effect is very noticeable in a habitat of this size and will create discomfort for some people, but it is adaptable within a few days. Creating an environment in space similar to Earth will allow us to use the same technologies used here instead of needing expensive, hard-to-maintain systems designed for microgravity. The saucer section will consist of two counter-spinning sections. The main section at 33 feet thick will house most ship systems. The counterbalance section at 6 feet thick will be filled with water ice and spun up to a speed sufficient to balance out the main section, will also act as an extra radiation protection. The structure of the ship will be 3D printed with aluminum into 1 by 1 foot hollow cross sections 1/8 inch thick, and the cavity to be filled with a polyethylene foam mixed with bismuth, both good for blocking radiation. The outer hull will consist of multiple layers of aluminum sheet and composite materials designed to withstand small meteorites. The Enterprise will be powered by 4 Rolls-Royce mini nuclear reactors providing up to 40 megawatts of electricity. The main propulsive drive units will be a fusion device known as the Helicity Drive, being developed by Helicity Space. This drive uses magnetic coils to compress deuterium plasma to high temperatures and create a fusion reaction, which is then released to produce thrust. Each deployment should be able to last up to 5 years, allowing enough time to explore large parts of the inner solar system. Further missions will need to wait for more advancements on energy and propulsion. Storing enough food for 5 years is impractical. Within the spinning saucer section of the ship will be an environment designed for comfortable living and to grow food and protein for the 40 inhabitants. Having fresh food will be good for the physical and mental health of the occupants. The systems used to keep the ship running will be many of the same technologies we use here down on Earth: power management, environment control, and more. Starting on the first floor where the gravity is at 1 g is the electrical room, which receives power from the mini nuclear reactors, uses large transformers that steps down the electrical voltage to be compatible with the ship's systems. These transformers are standard commercial systems with cooling systems that require gravity to work correctly and are much more affordable than building systems for microgravity. A water pump system is required to provide running water to the saucer section. All of the organic waste needs to be processed and recycled, so we start off with a closed-system sewer treatment machine. This separates and breaks down solids and liquids. Before recycling of some materials, they first need to be incinerated, and then the ash can be used in composting. This incinerator room takes special care to keep noxious gases from escaping and filtered. The composting area is used to take organic waste and turn it back into fertile soil for the plants. It also has a filtration system to keep gases and smells to a minimum. The electrolysis room takes water and splits it into oxygen and hydrogen. This system is to maintain the proper oxygen levels throughout the ship. Every place produces garbage. This area is for separating and shredding refuse to organize and prepare for its next phase in recycling. The water storage room provides the main water supply to the saucer section. The janitorial room will house all the equipment and materials to keep the ship clean. The laundry room will keep clothes and linens clean and fresh. The kitchen will be all electric and have an efficient air filtration system to keep smoke and smells down. The cafeteria provides a comfortable eating environment for up to 20 people at a time. There will be 5 rooms for living quarters, each housing 8 people. Each room will contain 1 restroom. The exercise room will allow crew to stay in shape and burn off excess energy. The game room will be good for relaxing and socializing. The infirmary will allow sick and injured personnel to be treated in a modern facility. Several restrooms will be available to the crew. The control room, or the bridge, which is modeled after NASA and SpaceX control rooms, is the nerve center of the ship, where command staff monitors all systems. The server room houses the ship's computer systems, which manage everything from navigation to life support. The air conditioning room will control the temperature throughout the saucer section. The condensers are connected to the clusters of radiators attached to the outer skin of the ship and is used to expel excess heat from the saucer section and the nacelles. The atmospheric balancing room uses the latest carbon capture technology from a company called Birdox to remove excess CO2. The other technologies will also balance the nitrogen and oxygen levels. The machine shop will provide parts and services to fix, repair, and maintain ship systems. The elevator and stairs will provide easy access to any floor in the saucer. The second and third floor of the saucer section will be for growing food. This will provide the crew with fresh, healthy fruits, vegetables, and grains to stay healthy and strong. The second floor will have individual growing pods to provide unique environments to allow each plant to grow in its ideal environment. The third floor will be dedicated to growing grains in a more open growing setup. The fourth and fifth floor will be for protein production, specifically chickens and pigs. The sixth, seventh, and eighth floor will be for the production of feed crops, grains, vegetables, black soldier fly larvae for protein. The remaining levels will be used for low-gravity research and storage. The new wave of autonomous humanoid robots will be used to perform as many of the ship's duties as they can learn, leaving more space for science and research. The main body of the ship will remain in microgravity, serving as storage for fuel, supplies, and spare parts. The front of the main body will house a landing vehicle and a docking system. The nacelles extruding off the back of the main body will house energy and propulsion. This separation from the main body will help protect the ship and its contents from possible radiation exposure. Having 2 nacelles will also add some backup safety in case one system is damaged. The ship will have the latest in imaging, ranging, and detection technologies that will allow for the proper survey and analysis of the structures of our solar system. 3 observation areas will be available to allow passengers to view the wonders of space. Many challenges will need to be overcome to make a concept like Enterprise a reality, but with the new heavy lift rocket systems coming online, it is no longer a science fiction dream, but an obtainable goal. We soon could have crew starships exploring the solar system, boldly going where no one has gone before.